All right. Good morning, everybody. So for the practice exam 3, I thought recording a video for you guys. So let's start. I already have the. I'm going to first do the uh, coding questions. Then, if we have enough time, I'll go over to small answer questions. So I already have the formatted file. Okay. So the first question. Given a CSV comma separated value file, write a Python function named count rows to return the number of data rows in the file. For example, your function must return 88 lines for sample csv.csv file. All right, so let's first open this file and then see, try to see the number, try to verify number of rows, whether it's 88 or not. So I recommend the same thing for you guys too. So the files are linked in the problem. So you click on the link, download the file, and first bring those file into the location in which you run your program. That's really important. Okay. So in my case, those files are here. Okay. So it's the student data sample CSV, I think. Let's see. Oops. Got that one. It's sample CSV. So let me open that file. Okay. So well, let's see. Let me open it in PyCharm so we can verify number of lines. Okay. So I'm gonna go here and open with okay, PyCharm. All right. Yeah, so we have 88 lines. Okay. So if you open this in a XLS program, unfortunately, I don't have XLS, Microsoft XLS. You will see this each of the row student ID, student, and then that student and the student ID going to be the next column, and the final score going to be the next column, and the letter grade is going to be the next column. So that's it's a comma separated value file. Okay. So let's go to our program. Okay, so right here. Okay, so all right, so let's start the umpire process. Okay, so first we need to so let's figure out the input. So input is input to the function. It's actually a file name, right? The file. So file. Okay, and let's say a file, and then output is going to be the number of lines. Okay, of lines. Okay, all right, in the file. So so that those are the two things. And then as part of umpire process, you should open this file in your text editor or in your spreadsheet program and verify the content, right? So then basically, right, open the file. Okay, and then basically we need to read the file. Okay, so this is a file for reading. Okay, and then read the file line by line. Okay, so that's what we have to do, because in order to count the lines, right? So we need to read, if we can read line by line, then we can basically count number of lines. Okay. All right. So that's the idea. So let's write our plan. Okay. So first step, input. Okay. So and then we need to open the file for reading, right? Reading. Okay. And then third step. Now to count the file, count the okay, so that's the match. All right, going back into the plan. So now we have to iterate each line of the file, right? So for that, we can iterate a text file in Python line by line. So in that case, basically, text file acting as the text file object is acting as a sequence of lines. Okay, not sequence of characters, sequence of lines. All right. So for a line in a file, okay. So let's say file object. So file object. We take FO. And then before that, we need a count. So we need to initialize the count. Okay. And then file, sorry, this is 4. And 4.1, we are inside the for loop now. Okay. And we need to, so we open the file. So we need to, we are basically reading line at a time. So we can now increment the count. Okay. So count plus equals 1. Okay. That's it. 5 return count. All right. So let's write our code over here. Okay. So we're going to use with statement to open the file. Okay. So open CSV file. Okay. I'm going to change it over here to. All right. So as file object. Okay. Now so we can copy paste this actually, this set of codes now. All right. So return count, and we need to initialize count over here. Okay. All right. So let's quickly test this out. Okay. So right over here. All right. CSV file, and then I already have the file name provided over here. So make sure right here you put your file, the location, same location that your Python file stays. Okay. Otherwise, you will have to put the complete path, full path to the file. Okay. All right. So let's run this. Okay. Should be question 15 actually. All right, so let's run it. All right, so there's a all right, so this is an unbound local error. So let's check for that. All right, so I think oh, It should be count. I made a spelling mistake. Okay. All right. Okay. So we got the answer 88. Okay. All right. So let me verify whether if I ask that or something else. Let's see. It. Yeah, we were looking for 88, so we got it. Okay, so let's quickly go to the second question. Okay, so question number 16, HTML files are text encoded markup files. In HTML, we use the paragraph tag to indicate the text between these tags are actual paragraphs. Okay, so write a Python function named count paragraphs to count number of paragraphs in an HTML file. So so we have to basically open this file as a text file in Python and then count these tags. So that's what we have to do. Okay, so so let's start our understand step. So input again, it's a HTML file. Okay, so okay, and the output basically number of paragraph. Okay, okay, so number of paragraphs. That's the output. Okay, all right. So how do we then calculate the number of paragraphs? We can simply count either of these tags. You can stick with the starting paragraph tag or ending paragraph tag. Okay, either one should be fine. Okay, so let's open one of these files. I think I should have it over here. Let's see. Okay, so let me just yeah, so how to study. So let's open with all right, PyCharm. Okay. So always do that. See that? So these were the tags that I was talking about. So every paragraph has a pair of the starting paragraph tag and the ending paragraph tag. Okay. So you can count at least one of these, and then that number will give you how many paragraphs do we have in this document. Okay. All right. So if we count manually, so this should be your understand step. You open the file in your text editor and count them manually. So 1, 2, 3, 4, 5. So there are 5 paragraphs. Okay. So let's go back to our program, and so manual count 5 paragraphs. Okay. All right. So matching is basically counting line is one matching program, because there we counted lines, right? So the one that we just wrote, the program that we just wrote is one match. Okay. So let's write our plan. Okay. So input an HTML file, and the output and again we need to open the file. So before that we need to initialize paragraph count. Okay, paragraph count, okay. and then to 0, right? All right, and then we need to open the file, right? So open the file for reading. Okay, and then step 1, step 2, step 3, step 4. Okay, so step 5 is you have to loop over, right? So for basically there are okay, so we don't need to loop over explicitly, right? So the program, let's say the question doesn't restrict using a string count function, right? So basically then we can open the file, we can open the file for entirely. Okay, so okay, so the other thing is if the file is too large, and that it's not recommended, so it's good to open the file line at a time, and then we basically count HTML tags in that each line we read. Okay, so that's the better way to open a file, because we don't know, if we don't know the size of the file, then opening the file, entire file into the memory would be not good. Okay, so and then there's no restriction to use string class method count, so you can actually use the count method. Okay, so for a line, okay, for lines in so say the HTML file object. Okay, and yeah, inside for loop now, so 5.1, and increment the count. Okay, so count, you can basically write paragraph count. Okay, and plus equals, so we read lines, right? So we get each line. Okay, we have each line, and then we now use the count method, because this line is now a string. Okay, so that string string class, so we can use the count method, count what, so we count either of these tag. Okay, so I'm gonna stick with the p the ending paragraph tag. Okay, so all right. Okay, all right, and then basically return paragraph count. Okay, all right, so all right, so let's, okay, so let's write our program. Okay, so we we need to open the file. So with open and then file reading for opening for reading. So we can just as HTML file object. Okay. Okay. So, well, I should have taken that number of paragraph. Yeah, that should have been better. Okay, so this is this step is not necessary, right? So I'm gonna delete that. Okay, but let's put this one as this. Okay, so it's 2, step 2, 3, 4, 4.1, and 5. Okay, so return this. Okay, number of paragraphs. Okay, so okay, so I'm gonna take this and just try. Oops. All right. So, all right, and I'm gonna delete this, hoping that I'll save time. 0, and we don't need that. We already opened the file. Okay, so 4 lines in HTML. Okay, so and here, then okay, all right. So think. Let's see. There you go. Okay. All right. So let's check this out now. See, I already have it. Let's go down at the bottom. Yeah, code paragraph. Okay. So on this one. Okay. So name error. A line is not defined. Did you mean lines? Yes. So I may have made a mistake there. Yeah, lines should be over here. All right. Let's run it again. Good. So we got the number 5. So the paragraph count is 5. Okay. All right. So question 18. Okay. So did we? Okay, we did. Sorry, it was actually. Yeah. 16. And it should go to actually 17. Okay. All right. Question 17. For a given integer n less than or equals 9, print a ladder of n steps. The kth step consists of the integers from 1 to k without spaces between them. To do that, you can use the sep and end argument for the function print. Okay, so basically, okay, so okay, so what we have to do is we have. I think I should get the examples. Go get the example provided. Okay, so. Yeah, so this is the example, right? So I'm going to copy this example. Okay, all right, so seems like the whole thing is missing there. Okay. Okay, so all right, so I don't need these 2 lines. Okay, so here's the example. Okay, so so for n equals 4, we have to print it like this: 1, 1, 2, 1, 2, 3, 1, 2, 3, 1. And you can see there's a clear pattern here, right? So it's basically printing line after line, and each line, that number that we print, that's a relation to how many numbers we print. Okay, so so let's try to make a good understand step of each of these iteration. Okay, so what I would do is basically, well, let me first write the input. Input is actually n. Okay, so n, and there are restrictions to n. Okay, so n basically 1, n, and it's basically between 1 and 9, right? So that's the restriction. So we don't need to worry about like printing more than 9 numbers. Okay, and then output basically we need to print a pattern, right? Print pattern given. Okay, so and then the match. Before that, let's try to understand what being asked, right? So basically, we have done a similar example, right? So basically, match 2 by 2 for loop or print pattern that we have done already several times in both previous exams. So those are match actually. So basically, you get a number and then you basically print that iteration up to that amount, that number, in a single line. So to print single line, okay, so use the end, basically print and end equals, right? Equals, in this case, nothing, right? So that's the end character. Okay, so basically we are printing first iteration 1, and then the second iteration is 1 and 2, and third iteration 1, 2, 3, and then fourth is 1, 2, 3, 4, right? So, and then you can see that in the first iteration we only print 1, the second iteration we print 2, right? So that iteration number has a relation to how many do we print. And you can see that this is a range of numbers, so you can simply use a range over here. Okay, so we can write it down as well, range. Okay, so as you realize things, write them down. Okay, use range. Okay, and each time in each iteration, the range n parameter going to be that iteration number. Okay, so this is the third iteration. So we can simply write, okay, I equals 1 and print 1, right? So print 1, and I equals 2, right? Print 1, 2. Likewise. So we can see the clear relation of I to the number of characters we print. Okay, all right. And we always start with 1. So, and it is the end that we need to sort of handle, okay, of the range. And it's a matter of printing in a single line, one after the other. So we first print 1 and then we print 2. Okay, it's not like we're printing 12 now. We first print 1 and then after that one we print 2. Okay, so all right, so let's go to our plan. Okay, so the plan is input, step number 1, input. Okay, input n and 2. Okay, so for numbers from 1 to n. Okay, right, and then we print it, right? So print numbers. So 2.1. Okay. So well, before that, so we are printing those numbers in a single line. So we need another loop for loop, right? For, so let's say numbers, we need another variable for that, from 1 to this should be numbers. Yeah, numbers. Yeah, right. So this many times, right? For example, if this is like right here, right? So this number is 2. So we are printing how many times? 1, 2. So that's our inner for loop. So this is the outer for loop, and this printing like this is inner for loop. This is okay. From up to numbers, we print it, okay, and then we print okay. Print numbers too. I'm gonna write it like this. All right, numbers too. Okay. All right, so that's the plan. So let's write our code. Okay. So for, I'm going to take it as I in range. Okay. All right. 1 number. Okay. All right. And then inner for loop for j in, well, one thing, if you are dealing with numbers, it is okay to use ing, okay, but not any other cases. If you are dealing with a line, don't use I. If you are dealing with a character or a word, please don't use I or J, right? So those are really vague, but for numbers, it's okay to use ing, okay? So in range 1 I plus, let me put I and see, okay? And then we print, okay, print, okay, print J, print in J, and end character equals this, okay. All right, and so let's print this one for now and then see what we get. Okay, so this should be okay. So 2.1, and this should be 2.1.1. Okay. All right. So this. All right. Okay. So 2.12. Yeah. Okay. All right. So let's try this one out. All right. So let's see what we get. All right. So we got a bunch of numbers printed. It seems like it didn't get into new line. So let's first fix that. The reason is this. So once you start printing in a same line, so this is that. So we basically override the default line separator with the end character. This, so it's all the characters going to be in a single line. So we are not altering after. So all the lines we're going to print, all the characters, all the digits we're going to print, all the things we're going to print, going to be in a single line. So that's not good. So we need to break it after it's done this for loop, right? So right here, right? So we need to break it. So to do that, at the end of that for loop, we simply print this. So in here, you know that the end character is new line with default, the default end character. So it's going to taken care of. So let's print it again. So we got it. So it's basically, well, for the line number 9. So it's right over here. Yeah, how many numbers we are running? Yeah, running it for 9. Okay. So we are basically getting up to 7, right? So we need to go up to 9. So there's still a mistake in our program. So it's a logical mistake. So let's fix that. So remember, we are actually picking our range up to number. This should be +1. Okay. And let's see if that would fix. Okay. All right. So we got it. Okay. So it's printing. And then you can see that there's a empty line printed over here. So, right. So I'm going to check the main method whether I am putting a new line there. Okay. So here it is, and it should be empty. So after this, there should be something over here, and seems like it's empty. So that means my the other range also wrong. Okay. So this range also need to be I+1. Okay. All right. So remember, ranges are exclusive, right? So the n parameter of a range is exclusive. So we'll only get up to, like, if it is the case, up to I. So we need to basically account for that extra excluded one. Okay. So we should be able to fix now. Okay, let's see that. And yeah, we are printing. Notice that after this, the one get printed. Earlier it was empty, right? So we got all the numbers that we wanted. All right, so there's a second method for this. So notice this program took 2 for loops. So we say this is a n square order. So because for the number, this number, we are actually running it that the square of that amount of iterations. So there's an efficient method for this, and then that's what the extra credit option mentioned in there, right? So for that, let's do that understand step. Okay, so the method 2. Okay. Okay. So I'm going to write these iterations in a table. Okay. So iteration I. Okay. And then print. I recommend using a spreadsheet. Okay. It's easy to create a table, and you can even copy paste. So analysis. Okay. Okay. All right. So the first iteration 1. Okay. 1 and print value will be 1, right? So we know that. And then the analysis. Okay. So let's leave that, and I'm going to copy this now. So next iteration is 2, right? Simply following the common sense, we iterate 1 and 2 likewise, right? So 2. So basically it's a print value 1, 2, right? So oops. All right. Right. So the analysis is basically, okay. So unlike earlier, we printed one after the other in a single so in a for loop. So if you are to get rid of that in a for loop, then sort of we need to sort of stick with numbers and then crunching those numbers, right? And then, for example, if we take this example over here, right? In the second line, we are printing 1 and 2, right? But instead of that, what if we write 12, right? If we can create the number 12 in this step, then we don't need to use the inner for loop to print one after the other, right? So the idea is that the reason is it's doable because we are only running this for 1 to 9, right? So that's many iteration, no more than that. So that means we can actually take this number and then write it there. If we can generate this number and write it over here, then we can get rid of inner for loop. Same way we generate 123 and then put it there. So that's the idea of that second method. Okay, so we have now 12. Now we need to figure out how do we generate 12 based on this iteration number, right? So if you let's write this for the rest, and then we'll come up with the analysis. Okay, so 3, and it's 1, 2, 3, and you can see a pattern also, right? See that we have 1 here, and we have 1 here, we have 2 here, and we have 2 here, and we have 3 here, and we have 3 here. Okay, all right. So, and the fourth one, and 4, and we have 1, 2, 3, 4, right? Okay, all right. So here is the analysis. Okay, so let's remember this is 1, so we have 1. It's basically simply the iteration I. Okay, and we have 12 here. So let's see, it's supposed to be 12. So how do we form 12? So we need a way to figure out how to form this 12 using this I. Okay, here's what I thought. Okay, so we can write this like this: 1 times 10, okay, plus 2. Okay, so so that's for now we can write it. Okay, so in we go to the next one, we need to create this number. Again, it has to relate to this I. So 1, 2, 3, right? Notice, right? So here we took this 2, which is I, and we have the same. If we get this 12, right? So 12 times 10, right? So basically, it's if we take this 3 out of 123, it's 120 plus 3, right? So basically, you can write it like this. Okay, and for the next one, okay, so 1, 2, 3, 4 equals 123 times 10, right? Right. Sorry. So 1230 plus 4. 1, 2, 3, 4. So plus 4. Okay. So we can clearly see I is over here at the end, and writing multiplying by 10 is constant always at every step, and you can see that the previous number 123 going to be in the next one. Okay, see that previous number is 1, and that 1 is over here. Previous number is 12, it's going to be over here. Previous number is 123, it's going to be over here. Okay, so we can now write our pattern basically equals, okay, previous. I'm going to get some more space. Oops. Our previous number times 10 plus I. All right, and it's the pattern. So it's basically, for many iteration, it's about finding that pattern, right? So all right, so if you want to verify, you can plug these values to this formula and you can get the value, right? So okay, so so this gives us sort of the idea of finding this pattern to implement in our for loop, the single for loop. Okay, so we can now write our code. All right, so okay, so let's see, sum equals 0. Okay, so we need that. Okay, because we are summing up numbers over here. Okay, so we need to initialize that, and the single for loop for I in range number plus 1, and it's supposed to start from 1 plus 1. Okay, in this case, remember our I start from 1. Okay, that's why it's starting from 1, and then sum. Okay, so first we need to calculate. First we need to calculate this part, this previous sum, this part. Okay, so that's previous sum, okay, times 10, right? So it's the star equals, okay, so we are multiplying by 10, right? 10. Okay, so it's like, if we take that example, 1 2 3 minus 3 equals 120, and how 120 form? 12 times 10. Okay, as equals basically, let me get it previous, this one. Okay, all right, so that's that. And then what we have to do is we have to add the value of I. Sum plus equals I, because see, we have to add that I after that, right? So that's that step. Okay, so so it's basically this step. So let me write an example. 1 2 3, sorry, equals 120 plus 3. So 3 is the I. So this is an example iteration. Okay, so this 3 is I. Okay, so so that's it. So then we basically, we got our number now. This sum gives us our number, so we print it. Print sum. Okay, all right, so so let's try this one out in the next. So yeah, we can simply run. It should be the second run. Okay, yeah, see that? Now, unlike, so in here, we printed a sequence of numbers without any space, but here they are actual numbers. This is 1, this is 12, this is 1 2 3, likewise. Okay, all right, so that's why it's single for loop, and it's actually efficient, because mathematical calculations, we use 2 mathematical calculations. Simple math calculations are considered one-time CPU cycle. So so it's a one-time process. So it's actually linear. So it's proportional to the number we pass to the function, right? Okay. All right. So next question is the class. It's really important. Okay. So let's okay. So all right. Okay. So write a Python class to represent a college student. A college student has a name, an ID number, and a major. When a student enrolls in a college, a student object is created and the name of the student is entered into a list accessible by every student. once enrolled, a student is not allowed to change the ID number. I think I need to let me just get the updated version. Actually, I added um, um, okay. So I think, yeah, we are good. So it has to be inside your class. So that's list. Okay. All right. Let's see. Yeah, I have it, okay, inside your class. Okay. So okay. So let's create a student class. So in this one, so what I'm going to do is I'm going to open a spreadsheet. Okay. So and basically I'm going to write the things that I have. Okay. So the names. Okay. The reason that if we create this table, it's useful because it allows you to identify names and an action separately. What are names? Names are going to be variables or data in our program, and the actions or behavior is going to be function that we write. And if a bunch of name belong to another name, that another name going to be a class. So this is that way we basically able to identify what's going to be the class that is complex data structures, and what going to be individual data, basically like numbers, IDs, names. Those are individual data, right? So and then actions. Okay. So so that's what I meant. So this sort of gonna act as your understand step. Okay. And later on, once you create this table, and then you can copy paste this whole thing into your code as well. I mean, don't worry about formatting, just copy paste it there. So that's going to be your understand step. Okay. So name. So first name, if you read our question carefully, right, it says write a Python class to represent a college student. So that's a name. You can write student, that's fine. So I'm gonna simply write this. All right. And we'll keep we'll leave the actions for now. Okay. So and then a college student has a name, an ID number, and a major. So these are also names: name, ID number, major. These are also names associated in names in our um, our our problem. Okay. So in here, since we are designing a class, I'm going to insert one more column and say we can write the association, sort of the relation between those names. All right, college student. The association is um, so let's grab the next name, the name, ID number, and major. Right, so we can write those. Okay, name, ID, and major. What's the association? Student has, right? Has, and it's basically like this. So this is a simple problem, right? Let's say a complex problem that involves like many classes, and then it'll be really helpful for you to identify who belongs what, or something like that. Who belongs who, or who belongs what, or what belongs to who, something like that, right? So those identifying those relations is really important. So then action is basically you can write actions involve college student, right? So those actions are uh, listed here, right? So And then if you design your class by creating table of names, that's this step. Okay. And then basically getters and setters, those are those are functions. So we need to figure out which should be suitable for getters and setters. Okay. And then basically implement string representation. Okay. Object, so basically printing the object properly, right? So and then there's not much actions involved in here. Basically the change of major, I think change the major of Ruby, which is so so that can be done using the setters and getters. So there's not many actions involved other than setters and getters. Okay, so you can write getters and setters. You know what they are. Okay. All right. So so basically identifying these association of these names to this college student. I'm going to change this name to student. Okay. It's important in this case. You may not see it as that useful, but if you have many classes involved, it's really important a step of basically design, right? So that's why. And then you can write anything that you seems relevant or connections between these entities. You can write them as well. Okay. And what I would do is this basically copy this and right over here. That's my understand tip. Okay. All right. All right. So this should be okay. So this phase, it should be fine. Okay. So student is the class, and then the student has this. And if you want, you can more elaborate this, like, you can add sub columns and then categorize that way. That's useful actually. Okay. So and then when you improve in coding, there are tools of designing classes like this. One is actually UML, it's Unified Modeling Language, UML. You can Google UML, and then you can learn about UML, how to use UML to design classes. Okay. But that's just pretty much the same thing. So it's there to help architects design systems. Okay. All right. So let's go over here. So we have to have names. So these student has a name, has an ID, has a major. So this means basically these data belongs to students. Okay. So that means when we write our class, okay, so don't forget to write the doc string. It basically start with a class to represent who or what. Okay, that should be enough for now. Okay. So we write our initializer. Okay. So this is the constructor. Okay. So let's write that. Okay. So define our constructor, which is init. Okay. And initializer taking care of initializing data we have, right? So that means we need to have this name. Student ID, I'm going to take that student ID, stid, just ID is because there's an ID function. So there's a sort of conflict between ID and ID number. Okay. So let me write it as student ID. Okay. And then major. So we're going to pass these three to initialize a student object. And then self dot name equals name. Okay. And then similarly dot student ID equals student ID. Okay. Self dot major equals major. All right. So self means we are initializing in the object that we're going to create. So this name belongs to this object that we're going to initialize by running this internal, which correspond to this constructor. Okay. All right. So that's the initializer. And then we can write the getters. Okay. So the reason, let me explain as we go over, right? So getters means basically accesses. So it allows to access from outside. Okay. So basically def. So in this case, right, more often, I think these days it's not like that, but like when I was attending grad school, they use the social security number as the student ID, which they changed later on because again, it makes it vulnerable to, like, at like hacking of those names, right? So but even these days, student ID considered as private data. So writing a getter for that doesn't make any sense because of security and privacy reasons. So in my case, if I wouldn't write a getter for this, okay, student ID. So I'll write a getter for get name. All right. And then basically itself, okay, and then return name. No, self dot name. All right, name. And next one is def get major and return self dot major. Okay, so two getters and setters. So let's discuss setters. What makes sense to change data? So once usually once a school create a student ID, it's never going to get changed. So we shouldn't write a setter for that. Okay. So but name, it's up to the student. Student has the freedom to change her or his name, right? So get so def set name. Okay. And to set the name, you have to actually have the new name to pass. So new name, we pass new name, and this is a mutator, right? So it doesn't return anything, it just change the name inside. So self dot name equals new name. Okay. All right. So the next setter is the major, set major, set. All right. So we need the new major. Okay. And then we self equals new major. Okay. And that's it. Those are the setters. And let's write the string representation. Okay. So if I'm going to stop here and then let's try this out now. Okay. And one thing we didn't implement is a list, right? So the student list. Create a student object. Okay. Let's see over here. Yeah. So not there. Sorry. I will reformat this lines. It's basically the student is entered into a list accessible by every student. Okay. Once enroll a student is not okay. So that's fine. So this is in here. I say Yeah, okay. I think this is the line. Yeah. So inside your student class, right? So that's what it says. Okay. So inside the student class, we need to have basically we need to access these names. Okay. So I'm going to put that list over here. Okay. So self dot list of students. Let me write it over here, and I'm going to explain why this wouldn't work. Okay. All right. So then once we basically initialize this, and then we need to add. Okay. So and then we basically, right, so that's the initialization, and then we basically dot add append, sorry, name. Okay, so that's what it's saying. List of students. Yeah. Okay. So yeah, append name. All right. All right. So let's run this one down here. Okay. So we need to first create 3 objects. Let's create 3 student objects. Okay. Okay. So Ruby Bridges. And student. So that's our class. This is our constructor. Okay. Make sure to pass the 3 parameters, the name, right? Copy this, and that's the name, and Ruby Bridges. Okay. And the next parameter is the ID 101. It's an integer, and major is American history, right? Okay. So all right. Oops. All right. All right. So similarly, so I'm going to copy the other, create other 3 students objects. Okay. And this one, James Meredith. James Meredith. Notice I use the same name for the object name. You don't have to do that. Okay. But it's more expressive that way. That's why I use. Okay. You can use student 1, student 2, which is fine. And James. Okay. And this is 102. And the next one is Helen Keller. Okay. Okay. So next example. And all right. So 103. Okay. So all following the same subject. Okay. So now I created 3 student objects. So I should be able to verify, right? I should be able to verify 3 students are in that list now, right? So let's do try to verify that. But before that, I'm going to print one of these students. Okay, so I'm going to see. Yeah, so create student objects. Yeah, so I created that. Change the major. Okay, so let's first change the major of Ruby. Okay, so what we're gonna do is let's first print Ruby Bridges. Okay, the object, and I'm gonna run it. So let's see. Okay, see in the question 19, I get this. Okay, so I mean this is not a. I mean, yeah, it printed something, but is it readable? No, right? So the reason is we didn't write that string representation of the object. So we are actually using the object class, because every object, every class in Python has the parent called object class, and that object class simply gives you the memory address where of the object basically. So this is where the memory is this the location of the memory of uh, the the Ruby bridges memory student object. Okay, and this is the module, basically the main module. We are running that program, so this is the main module, right? And the class is student. So simply it's following the dot notation and then giving this. So this is not useful if you want to print out what our object is about. So we're going to go back to basics and then to the top and then write the str method. Okay, and we can actually call it override it. So we are overriding what we are provided from object class. Okay, so def str. Okay, so and here we're going to return a more readable description of our student. Okay, so that's the idea. Okay, so in my case I'm going to write it like this. Okay, the student name and the major is major, sorry, R. Okay, and then we can write self dot name and plus can put a like this and then plus, and it's up to you to figure out which is better. Okay, so okay, all right, and then I'm gonna add the dot as well. Okay, so now let's run it and we'll see that a nice description gonna get printed. Okay, all right, see that the student name and the major Ruby bridges and American history. Okay, all right, so we took care of that, and we need to print now. Okay, so we need to change the major, right? So let's go and then change the major of Ruby bridges. So we printed that. I'm gonna print it like this, and Ruby bridges. All right, and then we're gonna change. So Ruby bridges, and we are changing, right? We can use the setter set major to political science. Okay, okay, so political science. So exam pass whole science. Wow, okay, that's a spelling mistake. Okay, all right, so and then we're going to print it again to verify. Okay, so always try to do that. All right, so earlier it was American history, now it's political science, so we change it. All right, so next one we need to do is we need to print out that list of students. Okay, so let's print out that as well. Print student list. All right, and need to sorry, we need to print student dot. Okay, well, notice that if it's not there, right? So I'm going to use one of the object and then let's print it. And also that this is wrong, I'll explain later. Okay, and dot list of students. Okay, so let's see that. All right, so and it didn't print anything, right? So let's see. print, spelling mistake. Okay. All right. So is there an error somewhere? Okay. Yeah, that's why print. Wow. Okay. All right. So let's see now. Okay. All right. See that student list? It only have Ruby Bridges name, but it should have, as per the problem statement, it should have all three names, right? The reason is this, right? So remember, we declared that variable. We'll go back to the constructor right here, right? But these data belong to individual object. Okay, so that means basically each individual student object is gonna have this list, but only that student's name gonna get inside, because this list is not belong to entire class. This list is belong to this the individual student object. So to change this, we need to actually declare a class variable or a static variable. So I'm going to take this out and initialize it over here. Oops. Okay. So write it over here and remove this. Okay. Now we can try this out, and then this should work. Okay. So well, let's try this and then see if it works. Okay. Okay, it seems it works. Okay. Now we have all three names. Okay. All right. But the still we can improve. I do not recommend using this way, using self. You can actually use the class name over here, which is the student. Because this is a class variable, it's belong to the entire class, not individual objects. So we're going to use it like this. All right. So the reason that it worked before is that because each individual object also have access to this guy. So we can use the self and dot notation to access it as well. Okay. So we run it and we get the same result. Okay. So either way is fine. I wanted to mention that this is this should be the go-to way, because other program language like Java only allow this. They don't allow the individual object to access the class or static data like that. Okay, so we better use the class name. Okay, all right. So that is the that I think that problem is now solved, right? Let's go to the next problem. Okay. All right. So next one is this finding trace. All right. Given an arbitrary square matrix as a list of lists, okay, write a Python function named getTrace to return the sum of all the elements in the main diagonal of the matrix. So basically, that is the trace. Okay. Okay. So this is well-known trace operation in linear algebra. Basically, you have a square matrix and then you have elements along the diagonal. If you sum up those, and that sum is the trace of that matrix. Okay. In this case, we have this matrix, and 1 plus 4 plus 1 plus this is the first element in the diagonal, and this one is here, the next element in the diagonal, 5, and 9 is the last. So 1 plus 5 plus 9 should return 15. So that's the trace. Okay. So right. So in this case, so we have 4 by 4 matrix. Okay. So we can get this example. So let's start the Ampere process. Okay. Input equals a matrix, right? Okay. So square matrix. Okay. may t x, okay, and the output basically trace. Okay. All right. So so basically trace, you can write it down as well, right? Trace is the sum of the elements on the main diagonal. So main diagonal is basically, okay. All right. So let's write an example. Okay. So I'm going to take this this matrix. Let's take this. Okay. So that's an example. So we now write it like this. All right. See, this is the diagonal elements. This is the main diagonal right here, one, and let me just get annotate. Draw. So this is, oops, that's not gonna work. I'm gonna draw that's not gonna work either. All right, so let's see. Oops, no. Yeah, there you go. So these are the main diagonal elements. Okay. So basically, then 1 plus 5 plus 9 is the trace. Okay. So right. So basically, 1 trace equals 1 plus 5 plus 9 equals, sorry, should be 5. That's equals 15. Okay. All right. So that's the idea. Okay. So all right. So so let's, I'm gonna remove this. All right. So okay. So what needs to happen? Let's figure out. This is a list of lists. So that's one way of Python. We can use Python to represent like two-dimensional like matrices, right? So it's a list of lists. That's why we have this comma over here. So each sublist have equal size. When that is the case, and then we have sort of like symmetric list, right? And if we have, and then each row is going to be one sublist, and if the number of element in each sublist equals the number of element in the outer list, then it's actually a square matrix. Okay, so it's clear that we need to basically access each sublist and then access it corresponding diagonal element, and then sum it out, right? So so that's what we have to do. Okay, so let's create that table again. So it's over here. Okay, so I don't need that. I may have written it earlier. Okay, so it's iteration. Okay, each iteration. So we're gonna write iteration 1. Okay, so and then the matrix row is this, right? So iteration 1, this is the matrix row. Okay, so the analysis basically, Okay, so we can write element 1, and that's basically 1. Element 1 is just 1, right? So this is the element 1, and then that 1 equals basically, if we take this as the matrix A, okay, so that's our matrix A, and 1 comma 1, okay, so that's the element 1, and that equals, right, A in terms of I, right? So if you want to generalize this, okay, so I comma 1, okay, sorry, I comma I, sorry, right? Because see that it's 1 here, over here 1, and then we access element 1, okay, so both I equals 1, so it's I, okay, so and then so this say yeah, so and then 2, I'm gonna copy this, it's easy, and we'll change the values. So this is iteration 2, and this is 4, 5, 6, right? So okay, so we are iterating a list, right? So each list item is going to be a sub list like this. Okay, so element 2 is element 2, and that value is actually 5, and then 5 is actually what? Again, right, 2 and 2, right? This 2 means this whole thing. This 2 means this guy. Okay. Basically, I mean, we'll have to deal with the indexing 0 and 1 likewise, but I'm talking about just indexing from 1. Okay, so be careful with that. Okay, if what I'm saying is suppose if this is 0, then it's going to be a little bit changed. Okay, and again it's I comma I, right? See that I is 2 now, and I is 2 now. It's I, right? And following the same pattern. Okay, so you can write 3, okay, 3, and it's this matrix, this sorry, sublist or row, okay, and that again element. So now it's element 3, right, and it's now 9, right? So what is 9? It's third row and third element. Okay, so again it's I and I. So now we can see this is the pattern. Okay, so we can run a single for loop and then grab these. Okay, so that's the idea. So so basically, and then at the end, basically the trace equals plus equals, and then these are right. So these values. Okay, so this is sort of the formula, right? Okay, so let's match. So this is going to be like any accumulation problem. We already solved few, so we can list them out as well. But this is just 2 by 2 list, so it's a list sort of iteration method. Okay, all right. The plan. Let's write the plan. Okay, real quick. We're running out of time actually. 1, and then input square metric. Right here. So okay, and then 2. Okay, so init trace. Okay, and number 3, 4 rows, because we're going to access each row at a time, so better to use rows in rows from column from one to number of rows. Okay. And then basically 3.1, add the element in square matrix, basically rows, right? Rows, comma, rows, right? So we need to add that to add this into trace. To trace. Okay. So this is the accumulation step. That's it. And we return trace. All right. So so that's that. So let's write this code. Okay. So we need to initialize trace. So this is our first step. Passing this variable into our function means the input. Okay. Yeah, getting the input to our function. So trace equals 0, the initialization, and then we basically for rows in range. Okay. So from 0, okay, 0 to, okay, len, okay, so length of square matrix. So this is what I was talking about, this 0. So we started over here with 1. It's actually going to be 0. That's the whole thing. It's not a big deal, but you have to account that for. Okay, and trace plus equals this, and we need to add. So it should be row and row, right? So rows, comma rows. Okay. All right. Okay, so that's it. So we return, and you can see that if you put your thought, it's actually really straightforward and easy as well. It's an easy extra credit question. Okay, so this is, let's check this out. Okay, for the oh, I didn't actually write my code, so in the tester. So let me just should be there. Testing question 20. Why didn't print it out? Okay. Oh, there's a mistake. That's why. Let's see what it is. The type error, list indices must be integer or slicer, not tuple. Okay, something right here. Okay. Oh, that's the mistake. All right, so there you go. That's the way we access, right? So I just followed the math and then put it there, but it's actually this way we access indices of a multi-dimensional list. All right, so let's run it. Still errors. So let's see. Oh no. Okay. Yeah, I got 69. So that's the expected answer. So now problem asks us to do this. I mean, this is the for loop iteration way, right? But problem asks, okay, you have to do this in a single line after the docstring. So we have to write it now. Once we have this one, that means you have to basically write a list comprehension, right? So that's the single line code means, right? So then once you basically, how do we convert this to a list comprehension? Instead of summing up, we have to write each this trace value into a list, and then we can actually sum up the value of the list using sum method. and we can return that. Okay, so that's what we have to do. So all the others, the rest of the code is sort of similar. So this for loop similarly going to go into our comprehension. Okay, so we can return. Okay, so it's a list. So we're gonna basically, what I'm going to do is I'm gonna grab all these 3 elements in the diagonal into a separate list. So that's the comprehension part. So we can write this. That's going to be our for loop in the comprehension. Okay. Okay, so I wrote that, and this basically, so now it's rows, right? So and then I need to basically get this. So this is at one point, one of these represent each diagonal element, because see, rows equals these two are equal, right? So the diagonal, so that's the diagonal element. So I grab this into my new list. So that's my new list. Okay, so if I run this one, I get the answer as the element of traces, sorry, elements in the diagonal. And if you take a look, so those are the elements in the diagonal in the 4x4 matrix given. But I need the trace, right? To get the trace, you need to sum. You can use the sum method, built-in method. Okay, so if you do that, and you get the trace, which is 69. Okay, all right, guys. So those are the answers to programming questions. I'm going to stop here because it's been already 1.5 hours, and I will post the PDF of short answer questions just now. Okay, so the file I'm going to post is a little bit maybe there may be some changes compared to this, but the same solutions should be there. Okay, let me see, I can actually post the same file. I just need some formatting to do. It will take time. All right. All right, good luck with the exam, guys.